हाँ 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 लाइव हूँ Hello everyone, a very warm welcome to all of you on the platform of Exampore. I am Sanjay Tomar, your maths mentor, and I welcome you all in this very important session what we have planned for you based on graph of linear equation, which was previously as well there, but now it is very clearly being said, so we will read it in detail, guys. Yeah, now we will read it in detail, guys, that what this topic of new graphs of linear equation does mean. What does this new topic graph of linear equation do mean? Okay, so come on guys, do join, and once you join, please do not forget to let me know by your comments as well. Once you join, please do not forget to let me know by your comments as well, guys. Do the sharings. Okay, hello mathematical study. Hello Harika, very good evening. Putin, Shrivani, Jivita Krishnan, Jivita Kathi Reshan. Very good evening, guys. Very good evening. So we are going to start off, guys. We are going to start off as of now only. We are going to start off as of now only. I hope you all are really well prepared just to gain the things, just to understand few things, just to understand few things. Okay. So all the very best and start it. So first thing is, guys, what is linear equation? A equation in which the highest power of the variable is 1. A equation in which the highest power of the variable is 1. Like, what do you mean by variables whose values are not known? Like x, y, z are variables. Their highest power is 1. Good evening, hero. Their highest power is 1 means x square, x cube cannot come. Only the maximum power is 1. Then only it is a linear equation. Then only it is a linear equation if the highest power of the variable is 1. If the highest power of the variable is 1, then only it is a linear equation. For example, x is equal to 2 is a linear equation. Y is equal to 5 is a linear equation. X plus y is equal to 7 is a linear equation because the highest power of the variable is 1. Because the highest power of the variable is 1. If it will become x square plus y is equal to 2, it is not a linear equation. This is not a linear equation because here the highest power is 2. So what is the first thing we learn? That in any linear equation, the highest power of the variable should be 1. Linear equation in one variable. Linear equation in one variable means only one variable, either x or y. So you can say, sir, x is equal to 5 is a linear equation. Y is equal to 7 is a linear equation. Only one variable, either x or y, either x or y. What is the graph of x is equal to 5? What is the graph of x is equal to 5? X is equal to 5 is a straight line. X is equal to 5 is a straight line. x is equal to 5 is a straight line which denotes that at every point x is equal to 5. So here x is 0, here it is 1, here it is 2, here it is 3, here it is 4, here it is 5. So guys, a straight line where at every point x is 5, a straight line where every point is 5, okay, at every point on the straight line x is 5, y is different but x is always 5, but x is always 5, okay. How can we make y is equal to 7 straight line? How can we make y is equal to 7 straight line? Y is equal to 7 is a straight line at every point y is equal to 7. 0, 1, 2, 3, let's suppose 7. So at every point y is 7. At every point y is 7. So this is y is equal to 7 graph and this is x is equal to 5 graph. Is these two basics thing clear? Is these two basics things clear? So can we now draw the graph of linear equations in one variable? Can we now draw the graph of linear equations in one variable? They are very easy to draw. They are very easy to draw. Okay. Now let's move on to the linear equation in two variables. Now let's move on to the linear equation in two variables. Like two different variables would be there. So, for example, x plus y is 7. X plus y is a 7. This is also a linear equation. Highest power is 1 and two different variables are there. Okay. So this is also a equation of a straight line. We will see how. This is also a equation of a straight line. We will see, bacha, how it is a straight line. I'm writing y is equal to 7 minus x. For different values of x, I'm plotting the different values of y. For different values of x, I'm plotting the different values of y. For x is equal to 0, y is 7. For x is equal to 0, y is equal to 7. So this is 0, 7, bacha. This is 0, 7. For x is equal to 0, y is equal to 7. So one of my point comes out to be, bacha, 0, 7. Now, for x is equal to 1, y is 6. For x is equal to 1, here y is 6, bit less. So this point. For x is equal to minus 1, y is 7 minus of minus 1, that is 8. So for x is equal to minus 1, y is 8. This was the position of 7, this was the position of 6, so this is the position of 8. This is the graph of the straight line. Is it clear? So we have plotted 3 points. One point was 0, 7, another point was 1, 6, and another point was minus 1, 8. Minus 1, 8. This is 0, 7. this is 1 comma 6 and this is minus 1 comma 8. If you join them, it will become a straight line. If you will join them, it will become a straight line, guys. If you join them, it will become a straight line. Now, every point on a straight line denotes a solution. Note. Every point on a straight line, every point on the straight line denotes the solution of straight line. Every point on the straight line denotes the solution of the straight line. If x is 0, y is 7, if x is 1. So there are infinite many points, guys. There are infinite many points on this line. If there are infinite many points on this line, so there are infinite many solutions of this equation. If there are infinite many points on this line, then there are infinite many solutions of this equation. Because points on the straight line denotes the solution. Since it is a single, straight line. So the single straight line has infinite many solutions. The single straight line has infinite many solutions. For example, you can take, sir, 7 comma 0 is also satisfying, 6 comma 1 is also satisfying, 5 comma 2 also satisfying, 4 comma 3 also satisfying. So there are infinite many solutions, bacha. How many? Infinite many solutions. So if in one equation there are two variables, there are infinite many solutions. How can we make it finite? How can we make it finite, bacha? By the intersection. We can make it finite by the help of intersection. Let's see how. Let's see how, bacha. How can we make it finite? One equation is x plus y is 3 and another equation is 2x minus y is 4. Now, two equation, two variable. So we have make it finite. We have make it finite. We have made it finite, guys, now. See how we have made it finite. I will write this equation as y is equal to 3 minus x. And I will write this equation as y is equal to 2x minus 4. And we'll try to draw both the lines. And we'll try to draw both the lines, bacha. Good evening, Sarathi. See. For x is equal to 0, y is 3. So one point is 0, comma 3, which is this. 0, comma 3. For x is equal to 1, y is 2. Another point is 1, comma 2. Another point is 1, comma 2. For x is equal to minus 1, y is 4. For x is equal to minus 1, y is 4. So this is of that fashion only. This line is of the previous fashion only. This line is of the previous fashion only. Now, for x is equal to 0, y is minus 4. For x is equal to 0, y is minus 4. So 0, comma minus 4. For x is equal to 1, this is 2 minus 4, it is minus 2. So for x is equal to 1, it is minus 2. Okay. So from here, it is now moving here. For x is equal to minus 1, For x is equal to minus 1, it is bacha minus 6. So for x is equal to minus 1, it is even lesser, minus 6. The point of intersection of these two lines will denote the solution. In case of two lines, guys, in case of two lines, the point of intersection of the two lines will denote the solution. In case of two lines, the point of intersection of two lines will denote the solution. So now there are infinite many solution or a unique solution, guys. Now there are infinite many solution or unique solution. Come on, tell me. Now there are infinite many solution or a unique solution. You will say, sir, there is a unique solution now. There is a unique solution now. Unique solution. And which is the point of intersection of both lines? Which is a point of intersection of both lines? What is this? Point of intersection of both lines. Point of intersection of both lines. So whenever, okay, so the unique solution, and that solution is the point of intersection of both lines. Why unique? Because they are intersecting at a single point only. Because they are intersecting at a single point only. So if they are intersecting at a one point, one solution. Yeah. And we can find out that point of intersection as well. And we can find out that point of intersection as well by putting the value of y from one equation to the another equation. From our childhood methods. From our childhood methods, like x plus y is 3 and 2x minus y is 4. So I can put y as 3 minus x in the second equation. So I can put y as 3 minus x in the second equation. 2x minus 3 plus x is 4. You will say, sir, 3x is equal to 7. So x is 7 by 3. If x is 7 by 3, by putting the value of y, x, we can find out y as well. So y is 3 minus 7 by 3, which is bacha 9 minus 7, 2 by 3. So point of intersection is 7 by 3, 2 by 3. Point of intersection is 7 by 3, 2 by 3. Now I have some questions. Could you answer me those? Now I have some questions, guys. Could you answer me those? Let's see, guys, whether you can answer it or not. Statement 1. Two lines will always give a unique solution. Two lines will always give a unique solution. Correct or not? Two lines will always give the unique solution. Two lines will always give the unique solution. Unique solution means single point of intersection. Unique solution means single point of intersection. Not necessary, bacha. Not necessary. Not necessary. False. False. Because three possibilities are there. Either they can intersect at a point. Either they can intersect at a point, which is a case of unique solution. Which is a case of unique solution, intersecting at a point, very good. Now, there can be one more case. Lines can be parallel as well. Lines are parallel means not intersecting at any point. Lines are parallel means not intersecting at any point. So not intersecting at any point means no solution. Not intersecting at any point means no solution. Bacha, if lines are parallel, then they are not intersecting at any point. And if they are not intersecting at any point, then there is no solution. Then is no solution. Okay. Yeah, you can take it as real as well. Okay. And these are intersecting lines. These are intersecting lines. So if the lines are intersecting, then definitely they are intersecting at a single point, and that point is like, what do you say, the point of intersection. Guys, what is the case of infinite solutions? What is the case of infinite many solutions in case of two lines? What is the case of infinite many solutions in case of two lines? What is the case of infinite many solutions in case of two lines? Infinite many solutions means infinite many point of intersection. Infinite many solutions means infinite many point of intersection. And infinite many point of intersection are only possible if they are one over another, if they are coinciding. If one is over another, then only they are intersecting at infinite many points. If one is over the another, guys, then only it is possible that they are intersecting at infinite many points. So one line, and over it is the another line, and over it is the another line, yeah, as well. So this is the case of infinite many solutions. This is the case of infinite many solutions. Coincident, yeah, coincident lines. Coincident lines, yeah. Got it, guys? Got it? Diagrammatically? Diagrammatically, guys, you got it? That when lines are intersecting at a single point, they will give the unique solution. When lines are parallel to each other, they will give the yeah, both equations in a certain manner. Mathematical, I will tell you that. No solution, both lines are parallel, and coincidental lines, infinite many solutions. Now let's derive their conditions. Guys. Let's derive their conditions. Bacha, let's suppose the lines are a1x plus b1 by is equal to c1. Obviously, it is a straight line, and the way of representing a straight line is ax plus b by is equal to c. And another straight line is a2x plus b2y is equal to c2. Another straight line is a2x plus b2y is equal to c2. You might be knowing the slope, guys. How can we find out the slope? So slope we find out in this manner, that b1 by is equal to c1 minus a1x, or y is, just a minute, yeah, minus a1 upon b1 x plus c1 upon b1. On comparing with y is equal to mx plus c, the slope of the line comes out to be minus a1 upon b1. On comparing the line with y is equal to mx plus c, the slope comes out to be minus a1 upon b1. So first line slope. Can I say the slope of the second line is? The slope of the second line is minus a2 upon b2 for sure. You should not be doing this, guys. You should not be doing this. You should be directly writing the coefficient of x upon coefficient of y with the negative sign. Coefficient of x upon coefficient of y. Coefficient of x upon coefficient of y with the negative sign is the slope. Coefficient of x over coefficient of y with the negative sign is the slope. So this is, we have done it for the first and the last time. This is what we have done it for the first and the last time. Now we would be directly writing, yes Ganesh, this is right, we are reading for CGL. Coefficient of x upon coefficient of y with the negative sign. With the negative sign. Okay. Okay. So now let me show you guys. Now let me show you the magic. Now let me show you the magic. Lines intersecting. Lines intersecting, bacha. Just draw them in the coordinate axis. Are their slopes equal? No. Are their slopes equal? 100% not. It is moving towards, it is moving. So if two lines are intersecting, their slopes are not equal for sure. If two lines are intersecting, their slopes are not equal for sure. Slopes are not equal. So minus a1 upon b1 does not equal to minus a2 upon b2. So you will say, sir, a1 upon a2 should not equal to b1 upon b2. This is the condition for intersecting lines. a1 upon a2 does not equal to b1 upon b2. This is the condition of intersecting lines. a1 upon a2 does not equal to b1 upon b2 is the condition of intersecting lines. Now, if I take the parallel lines, bacha, let's see. If I take the parallel lines, bacha, guys, can I say their slopes are equal? Can I say their slopes are equal? Parallel lines. Yes, they are making the same angle with the x-axis. If you extend them, they would be making the same angle with the x-axis. So, you know slope is equal to tan theta. Slope is equal to tan theta as well. Slope is equal to tan theta as well. So, if theta is equal, tan theta will also be equal. If theta is equal, tan theta would also be equal. So, in case of parallel lines, slopes are equal. In case of parallel lines, slopes are equal. So, m1 is equal to m2. What was m1, bacha? It is minus a1 upon b1. And what is m2? Minus a2 upon b2. a1 upon a2 is equal to b1 upon b2. Guys, what about c1 and c2? Would it be equal or not? What about c1 and c2? Would it be equal or not? Come on, tell me. What about c1 and c2? Guys, their intercepts are different. Intercept. Like, this is the intercept on the y-axis for this line. And this is the intercept of this line on the y-axis. So, if the intercepts are different, If the intercepts are different, then you will say, sir, it does not equal to C1 upon C2. So parallel line are two different, parallel lines will form different intercepts. Parallel line will form different intercepts. So if the intercepts are different, definitely it should not be equal to C1 upon C2. Got the point, guys? Got the point? Got the point? Now, what happens in case of coincident lines? What happens in case of coincident lines? What happens in case of coincident lines? One line is going like this. One line is going like this, and another is traveling over it. Now, even their slopes are equal, and even their y-intercept is also equal. Even their slope is equal, and their y-intercept is also equal. थोड़ा बड़ा बनाएं इसको to have more fun. Even their slopes are equal, and their y-intercept is also equal. Now, coincident lines are the case where their slopes are also equal and the intercept is also equal. Where the slopes are also equal and the intercept is also equal. So what is the condition of the coincident lines then? You will say, sir, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is the condition for coincident lines. Now guys, I will ask you one more thing. Coincident lines means how many solutions? Coincident lines means how many solutions? Coincident lines means how many solutions? Infinite. So this is also the case for infinite solutions. This is the case for infinite many solutions. So A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2 is the condition for infinite many solutions. We have connected both. Parallel lines means, bacha, what? Parallel lines means what? Parallel lines means what? No solution. Because not intersecting at any point. Not intersecting at any point. So, this condition is the condition for no solution. So, this is the connection, guys, what we have established. This is the connection what we have established. The condition of parallel lines is the condition for the no solution as well. The condition of parallel line is the condition for the no solution as well. The condition of the parallel line is the condition for the no solution as well. And what about this intersecting lines, bacha? What about this intersecting lines? The condition intersecting lines means? Intersecting lines means, bacha, unique solution, single solution. Intersecting lines means single solution. So this is the condition for unique solution as well. This is the most gajab part of this teaching. When I teach this, guys, this is what I love the most. and I hope you might have also. This connection when I establish, guys, this is the point which I love the most, and I hope you too. Okay? Great. Great. So, see, guys, how many solutions these line have? How many solutions these line have? Directly go for the condition A1 upon A2, B1 upon B2, C1 upon C2. As simple as this. Just go for it. A1, 4. A2, 2. B1, minus 1. B2, minus 8. Okay. Okay. So, hero, what you have done? What you have done, beta? Hero? Okay. So, A1 is 4. Acha, this is 2y, na? This is 2y. The coefficient of x is minus 8. Minus 8. And the coefficient of y is 2. Check the C1 upon C2 as well. Check the C1 upon C2 as well. 2 over. If you have taken this over, guys, take it over there as well. It will become minus 4. It will become minus 4. If at one place it is after equal to, so take it after equal to here as well. Take it equal to after here as well. So it is minus 1 by 2. It is minus 1 by 2. And this is minus 1 by 2. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is going to have infinite many solutions. This is going to have infinite many solutions. Interesting question. Interesting question, bacha. Come on, tell me. Interesting question. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So this is the condition of infinite many. This is the condition of infinite many solutions. So you will mark the answer as infinite many. They are, if you take anything common, na, if you take anything common, bacha, they are exactly the same line. Like if I write it as minus 8x plus 2y as minus 4 and will take minus 2 common, it will become 4x minus y is equal to minus 4, and when I simplify it, it will exactly become the first line. It will exactly become the first line. Can you visualize it now? Can you imagine it now, guys? So if two lines are exactly same, definitely they are coincident. And coincident means infinite many solutions. Coincident means infinite many solutions. Coincident means infinite many solutions. Chalo, I hope it would be clear now. For what value of k, these graphs are parallel. For what value of k, these graphs are parallel. Parallel means A1 upon A2 should be equal to B1 upon B2. A1 upon A2 should be equal to B1 upon B2. A1 is K minus 1. A2 is 2 minus K. A1 is K minus 1. A2 is 2 minus K. Should be equal to B1 upon B2. B1 is plus 1. Please take care of the sign as well. Please take care of the sign as well. B1 is plus 1 and B2 is minus 3. Here also the error happens. You have to take the value with the sign. You have to take the value with the sign. So please take the values with the sign. If you don't do it, you will get it wrong. You will get it wrong. Cross multiply minus 3k minus 1 should be equal to 1, 2 minus k. Minus 3k plus 3 is equal to 2 minus k. So take it over this side and take it over that side. 3 minus 2 is 1 and this is 3k minus k. So 1 is equal to 2k. K is 1 by 2. So k is 1 by 2. Please take the coefficients with the sign. If you don't do it, you would be in trouble. If you don't take the values with the sign, you would be in a trouble, which I don't want you. Is it clear? Is it perfectly clear? Is it perfectly clear? Okay. Let's move on to the next question. Very less interaction. Very less interaction, guys. Okay. Same, simultaneous. That is same. Yeah. Two variables. This is one of the equation. This is another equation. To have infinite many solutions. To have infinite many solution, what is the value of k plus m? To have infinite many solution, what is the value of k plus m? To have infinite many solution, what is the value of k plus m? Infinite many means a1 upon a2 should be equal to b1 upon b2. A1 upon A2 should be equal to B1 upon B2 and should be equal to C1 upon C2. Should be equal to C1 upon C2. Should be equal to C1 upon C2. Now, from these equations, I will find out the value of K. So, K is coming out to be minus 36. And from these two equations, I will find out the value of M. So, minus 1 by 4 is equal to 12 by M. You will say, sir, M is minus 48. K is minus 36, M is minus 48. What is K plus M? What is K plus M? So, K plus M is minus 36, minus 48, minus 84. Guys, all logics built now? All logics built now, guys? All logics built now? What do you think? So in the future, guys, in the future, I will take one more session over it where I will take the complex equations involving x, y, z as well. In the future, guys, I will take one more session over it. Till now, guys, I have only taken x and y. Now, in one more session, guys, which I will plan in the future, uh, I will take up those questions where three variables also come. I will take up those questions where three variables also comes. Okay, it is about the now. Today's session was all about the conceptual part. All the concepts are clear. All the concepts are clear. Now, in the next, it is only about the solving different type of problems. Whatever the next session, guys, whenever I will take it, it is only about, guys, the problem solving of different types. Problem solving of different types. I hope, guys, whatever the concepts I have delivered today, all of them are like absolutely clear. If some of them is still remaining, you can ask me. If some of them are still remaining, guys, you can ask me. Because I have seen the time, it's 46:48. So, Jed, I am not bringing today. Jed, I am not bringing today. We'll think, Putin, we'll think, Mr. Okay, I have to arrange some questions as well. Okay. So, very soon, guys. Not, I will not take too much of time. I will not take too much of time, and that would be included in the playlist. Okay, so do not worry about it. Do not worry about it, bacha. Three variables, we will start it on the other fresh day only. Three variables, we will start it on the other fresh day only. Okay. So take care of yourself. I hope you might have thoroughly enjoyed the session. You might have some good learnings through it. If it is the case, then please do not forget to let me know in the comments. Yeah. If this is the case, please do not forget to let me know in the comments. If this is not the case, then also please, no, I think Jeevita, I am not going to take it today. So if that is now not the case, then also let me. But do let me know, guys. Whatever you want to tell. Just okay. So take care of yourself, guys. Have a great time. I believe, guys, that all of you might have definitely joined the guys Exampur platform for the app. Which consists of lot of features, guys, which I used to tell every day, every morning, every evening. So there would not be even a single guy who is not aware of these things. So please, guys, please do it. Please do support us so that we would be doing more innovations and more good things for the success of students. So we would be doing more innovations, more good things for the success of students. Take care of yourself. Have a great time. See you in the next session.